So in a sedimentary rock, the diameter of two grains A and B are 1.5 and 3.5 respectively. They have to calculate the difference between the diameters. So first thing, the relation between phi and diameter, it is like this: pi equal to minus log 2 d. So d, it is the diameter of the grain, d, it is the diameter of grain, region mm. So if phi is minus log 2d, then d will be, then you can write down like this: minus pi equal to log 2 d. So then d will be 2 to the power minus pi. This is the relationship, d equal to 2 to the power minus pi. See here, it is given the sedimentary rock, the diameter of two grains are 1.5 and 3.5. So A, it is given 1.5, B, it is given 2.5. So you have to calculate the difference between the diameter, 3.5. So you have to calculate the difference between the diameters of A and B. So first we'll calculate the diameter of A, it will be 2 to the power minus 1. Then diameter of B will be 2 to the power minus 3. And this one 0.125. So I have to take the difference. So the difference will be 0.5 minus 0.125. 0.375. So we have to round up to 2 decimal. So after 2 decimal 5 is present, so we have to round up it. So if the third place it is 5 or more than 5, so the round up will become 0.38. So answer will be 0.38. Now from the data shown in the table, the weighted mean size in micrometer, so correct up to 2 decimal places of the segments. So weighted mean size formula for weighted mean will be summation of wi xi divided by summation of wi I 1 to n. So this is your wi given, this is xi. So first we will calculate wi into xi. Then wi into xi, it will be total 29700. Then summation of weight, it is 300. Then just divide these two. So weighted mean will be 9700. So here the unit will be in gram into micrometer. Okay. Here the unit will be in gram. So that's why the weighted mean will be found in micrometer. It will be 32.33 micrometer. 32.33 micrometer. The ripple symmetry index for the given hypothetical asymmetrical ripple. So ripple symmetry index, it is calculated by ripple symmetry index. It is starch side length of the starch side divided by the length of the lee side. So here flow direction is given, so that it will be starch side, this one will be starch side, this one will be lee side. So simple, 10 by 4, it will be 2.5. 2.5. So an ocean wave with a wavelength of 200 meter approaches the coast. If the water depth at the observation point is 75, so you have to calculate the wave velocity. So here, if you want to calculate the wave velocity, first you have to know whether it is a deep water wave or shallow water wave. Correct. First you have to know whether it is a deep water wave or shallow water wave. If depth of wave, it is greater than equal to half of the wavelength, then it will be considered as deep water wave. It considered as deep water wave. If it is deep water wave, then the velocity is calculated is 1.25 root over of L, where L in meter. L is in meter. If you have to calculate the velocity of a deep water wave, then it will be 1.25 into root over of L, if it is a deep water wave. So first we have to check whether it is a deep water wave or shallow water wave. So next, if depth of wave, it is less than equal to 1/20th of wavelength, then it will be considered as shallow water wave. Shallow water wave. So here you can calculate velocity is equal to 3.13 root over of depth, where d in meter. And in between these two, if the depth of wave means, this is called as a wave base. Okay, this is called wave base. It's called wave base. And in between the value 1/2 to 1/20, it will be transitional wave. So in the question it is given 75, it is the depth, and wavelength is 20. Wavelength is 200 meter. So L is given 200 meter. So first we'll take 200 by 2. It is 100. So this value it is 100. So if the depth is greater than 100, if the depth will be greater than 100, then it will be considered as deep water wave. But the depth it is actually less than half of the wavelength, and also it is greater than this condition also. If you will take 1/20th of length, 200 by 20, it will be 10. So the depth of wavelength, it is actually greater than for shallow water, less than deep water. The condition. So it will be within transitional zone. It will be within transitional zone. So for this, there is no velocity calculation formula for this, but this is taken as for velocity calculation. Okay, so velocity will be 1/1.25 into root over of wavelength. It will be calculated in where L is in meter. L is in meter. So length is given 200 meter. So the velocity will be 1.25 into root over of 200. It will be approximately 17.50. 17.50 meter per second. So 1 meter deep and sheet-like water flow on a sandy beach develop antidune. So it is saying 1 meter deep sheet-like flow. So it is upper plane bed. It is saying upper plane bed, because if velocity on the upper plane bed will increase, it will convert to antidune. So here Froude number is 1, because upper plane bed it produced during critical condition. It will produce during critical flow. So it will produce during critical flow. So during critical flow, F is equal to 1. So the minimum velocity of the water flow was dash meter per second. So was it is given for upper plane bed. It is not asked for the antidune. It is asked for the upper plane bed. So that's why F equal to V by root over of GD. So F is equal to 1 V by root over of GD. So V will be root over of GD. G is given your 10, and the depth is given 1 meter. So it will be root over of 10 with 3.16. So fraud number 1, it is because that is it is a upper plane bed, because if you increase the velocity of a upper plane bed, if you increase the velocity of flow on upper plane bed, it will convert to antidue. So it is asked what was the velocity, what was the flow velocity during upper plane bed condition. So water flow transports spherical particles of diameter 2 mm. So D is given 2 mm. Then density, it is given 3 gram per cc. So it is rho s, particle density in suspended mode. If additional particles of density 2 gram per centimeter cube are added, so we will take another particle, rho s1 will take, that is 2 gram per cc, are added into the flow. Then the diameter of the particle that can be transported without a change in terminal velocity using Stokes law. So first we have a particle that has a diameter 2 mm, it has density given 3 gram per centimeter. So first we have to calculate the fall velocity of, for this particle. Then without changing the fall velocity, we have to calculate diameter of another particle that has density 2 gram per centimeter. So first we will calculate the terminal velocity of particle 1 will take. So it is given 2 mm, rho s given is 3 gram per centimeter cube, rho f it is given 1 gram per centimeter cube. So it will be g 2 mm square into rho s minus rho f, 3 minus 1 gram per cc divided by 18 mu. Okay, so Vt1 equal to g into 2 mm, diameter is given 2 mm, then 3 is your particle density, it is fluid density, then 18 mu. Then Vt2 if you will calculate, it will be g d square. So for T, the density of water will remain same, but the density of the particle, it is changed to 2 minus 1 divided by 18 mu. So here it is given that this one is equal with this one. So you have to the terminal velocity will not change with the change in density of the particle. So that means these two we can equate. So terminal velocity 1 is equal to Vt2. So it will be g into 2 mm square, 3 minus 1 gram per cc divided by 18 mu equal to gt square, 2 minus 1 divided by 18 mu. So 18 mu, g, they will cancel with they will cancel each other. It will be 2 square mm 4 mm square divided by 2 will be equal to d square. So calculate d, it will be 0.28 centimeter, or you can say we will directly calculate 2.8 meter, 2.8 mm. So, value of phi of a sediment grain having diameter 0.125 mm. So phi, it will be minus log 2 d. So d it is given log 2 d is given 0.125. So in simpler way you can do 125 by 1000, simple. So minus log 2 will be 1 by 8 equal to minus log 2, it will be 1 by 2 to the power 3 minus log 2, it will be 2 to the power minus 3 log 2, 2 base 2 will be cancelled, minus 3 it will be plus 3. So answer will be 3. Okay, the simpler way to kariyo. So the mean flow velocity of a water in an open channel having an average depth, it is given, depth is given 0.2 meter with fraud number F is given 4. So we have to calculate the velocity. So G is given 9.8 meter per second. So the formula of fraud number F equal to V by root over of GD. So we have to calculate velocity. So velocity will be F into root over of GD. So F is given 4, G it is 9.8 meter per second square into 0.2 meter. So it will be 5.6 meter per second.